Oh yeah, but that's another.
That's another one. Submit. Just checking your spam filter. Effectively. It will come in. Voilà. And it's in the speakers monitor as well. If you've got the slides, do you want to see if that USB thing for that works? Somebody can make money doing a USB data diode. You know, this. I know.
No,
I'm with you. I don't like it.
Yeah, I don't want to, add the more.
Yeah, more crap to your machine.
I've been
there one too many times.
so long time to production environment. So,
Yeah. No, I did.
and
Yeah.
I don't want to have something that works or that the last minute. Yeah, no, sorry. So we start.
Good morning, or
Very good morning.
late evening, good, whatever, wherever you are on the planet. IETF DTN Working Group.
The date's wrong.
Oh, yeah, I did this. Oh, actually, that's not, is it the right? Wait a minute. I think it did the right one. I think no, it's right. Okay, sorry. Last minute changes. This is the proposed agenda. So a lot of things on the agenda. Main priority is obviously to close TCPCL. And that in some ways should be our very first priority, so we'll take whatever time to finish it. And then BPSEC, AMP, and ADTK, and bundle and bottle. Any agenda bashing or changes? Yeah.
Just a few words about the TCPCL work. I know Brian has been working very hard on this. He's put out some latest updates very recently. I asked Victoria to sort of collate most of the outstanding issues that were circling on the list and some of the ones she'd worked with herself. That's less of a presentation about what various people think is wrong. It's an opportunity to discuss in the working group here, while everyone is currently paying attention to TCPCL and DTN in general, just to make sure that we have the consensus of the room and the list and Meet Echo, so that we can really get some consensus on the behavior that's expected at the TCPCL there, hopefully get the resolutions minuted, and then Brian, with assistance from anyone who is feeling generous, we can just get this done, because it's bunging up the working group, as we well know. We've got good documents that are holding, waiting for the triumvirate of BPSEC, BPBIS, and a interoperable transport for the three. So that's the reason it's there. And unfortunately, if some of the later things on the agenda get pushed out, they are of a lower priority than TCPCL. So.
Ed, are you able to take notes as usual? Thank you very much. So this is actually the almost exact last slide as last time. We were going to send the two documents to ISG, and so let's try to fix this. And these are the milestones we have. So without further ado, let's start with, yes, go ahead.
Do we have a Jabber scribe? Can somebody watch Jabber and take the questions to the mic? Thank you.
That was too fast. So we'll try a remote presentation again with Brian. Whoops. Oh, okay, I need to put it there. Okay.
You want to click something?
Usually, right?
In the queue?
And then I think you put the, yeah, mute. Yeah, unmute. Yeah, one. Brian, I will be your clicker for changing slides, so tell me when.
Okay. Hey, good morning. Yeah, there are very few number of slides here, just really a summary of the draft, the last two sets of draft changes. So you can move on to the next. This is just an overview of the presentation, so not really much information for what we're doing. You can move on. So I've included this slide yet just for background to anybody that is reading this fresh, but this hasn't changed since the original IETF that I presented this on. We're still trying to do the same thing and refine the draft to be able to do this in a consistent way. So you can go to the next slide. And one of the major goals is not to change behavior, workflow, or scope from the original TCP/CL. And as I'll talk about, one of the last things that got missed in an earlier edit was the negotiation of the reactive fragmentation, which is in the last 07 draft, been added back in a form. You can go to the next slide then. So there was a number of comments that were included in the 06 version of the draft. I tried to go through all the comments from review and either address them by an actual change in the draft or respond to the comments on the mailing list email. I did add a section to the front matter. I think it's section 1.1, which is the convergence layer services. So this should help the understanding of exactly where the line is drawn between the CL and the bundled protocol agent. We can get to it in more detail later on, but there was a comment or question from Victoria about whether this was intended on being the complete and exclusive list of what the CL provides. And my short answer to that for right now is yes. I think it is supposed to be the exclusive and complete list of what does the CL do. And for that last point on this slide, all of the edits that were made in the 06 draft, I believe were to, many, not all, were made to fix up wording and reconcile requirements that a lot of them got inherited from the version 3 protocol draft, and really just simplify things, trying to get away from more lower level details about messaging and flags and make the requirements a bit more on the workflow and the expected sequencing of things. And section 3 then becomes a lot of more description of the protocol and less of actual requirements. So section 3 is an overview to an implementer or somebody who's trying to troubleshoot the protocol, and then the later sections become actual protocol requirements. So next slide, please. And I didn't realize until it was too late, until it was the day after the cutoff, but I had been making later edits to my own copy of the draft, which is now version 07, but I missed the cutoff, so they did not get included until relatively recently. So there were a couple of services, and these changes are relatively sparse. There were a couple of services that were missed as far as, again, this listing of services is supposed to be complete. So the obvious one of actually initiating a transmission was missing. So that was added in. And there was a little bit of touch up in the services listing. One of the actual changes in behavior that was done in the 07 draft was to add back in from TCP/CL v3 negotiation of can an end of the CL session do reactive fragmentation. So I'm sure we'll discuss this in a few minutes, but the intent of this as an extension header is a couple of different things. One is that it's not really the convergence layer that's doing any of the logic for reactive fragmentation itself. It's really the BP agent that's doing this. The reason for that, and it's described a little bit in the draft itself, but the reason for that is that by the definition of how a transfer can fail, at the point the transfer has failed, the TCP/CL session really has something go bad in it, and the session effectively will be either closed by one of the endpoints or will have failed at like an operating system TCP socket layer. And the TCP/CL session and the TCP/CL itself is a bit useless from the point of view of doing the reactive fragmentation, either for generating the reactive fragments or for reassembling them. So this is a BP agent task, and the only thing that the CL can do in terms of this reactive fragmentation behavior is to negotiate and signal whether each of the ends of the session is capable of supporting this. So for that's one of the reasons. The other reason is that after hearing discussion on the mailing list about what reactive fragmentation really should involve, and even in seeing some of Victoria's late comments that we'll discuss in a bit, there are still kind of, in my mind, different notions of what reactive fragmentation can possibly represent. And so by moving this into an extension item, what it really represents is that what's negotiated in the 07 version of the draft is this particular variation of reactive fragmentation as an optional behavior. And if somebody wants to come up with their own late variation of what reactive fragmentation should be and how it should be parameterized, then that can be accomplished through a different extension item and be, as far as this is concerned, not necessarily directly affecting the TCP/CL segment of either end of a session. So the CL is used for signaling this information, but it's really the BP agent that is going to actually be acting on it. And then the last change is the simplified shutdown behavior. Again, similar to the other later edits, the requirements were changed from a relatively lower level set of statements about the individual messaging to something a bit higher level, to just state that during as soon as the shutdown is initiated, you can't initiate any further transfers. And there's still, both in the draft and as an item here, that there's still the prerogative of the CL node itself to simply decide that it doesn't want to actually complete a shutdown and it just wants to close a TCP connection for whatever reason. And if there aren't any in-progress transfers, that's basically a clean version of closing a session. But if there are any in-progress transfers, it just causes the transfer to fail. So shutdown is the clean way of avoiding transfer failures, but a CL node can always just close the TCP connection and possibly fail some transfer. So next slide, please.
You're on the wrong window.
No.
Is that the last slide?
There's one more after.
You got one more slide? Nope.
No, that's the last.
So that was the last slide
Oh.
we've got, Brian, sorry.
Oh, I'm sorry. I must have condensed this thing. Yeah, this looks right. So the 07, I know the 06 version is what was on the agenda, but there is a 07 version that makes those late changes in some areas. And this was something that I know was mentioned real recently in the mailing list, and I'm not sure if it's worth including in the TCP/CL draft itself, but there is an updated working implementation, the real basic working implementation of the TCP/CL v4, and it is something that could be included as a URL reference and some text in the draft itself.
It's an RFC, I can't remember the correct quote, but
Whatever.
it always helps, yeah. Sorry, Scott, I was holding your question just because it's very difficult with me, Tecker. Do you still have a question? Okay, so it's a no. Thanks, Brian. Obviously, stay on the call because we're going to move straight on to hopefully Vicky's got a little bit of a presentation on this, and then we can try and get a discussion. Go on, Brian.
Brian Everman. So Rick caught me in the bar, I think, and said, hey, can you give this a read? And I did, and thinking of this from the point of view that having been sitting in Rick's chair, I understand DTN, but I haven't actually implemented TCP/CL before. A couple of things jumped out at me. One was when you do something like a shutdown for a version mismatch, don't you end up opening yourself up to essentially losing potential connectivity if you know how to speak the older version? So should the contact header have some indication of what version of TCP/CL you support so that you could actually negotiate which version to use?
There was earlier, I think, a similar comment on this, and if I remember right now there is in the draft language about that a node should start at its highest supported version, and if it supports multiple versions, to work down the list. So there is language in there about attempting multiple versions, but not from the perspective of like what you've just mentioned, where it's upfront exposed, these are the versions supported.
Right, because I would think that what you would really want to be able to do is keep the TCP session open and just send a new contact header with the next version down that you support, so that you don't actually tear the TCP session down, because you don't want the three-way handshake to occur again and again.
For me, this was really just holdover behavior from the version 3 of the protocol.
Yeah, and that's what I was expecting when you started the comment saying you were trying to stay as close to the TCP/CL v3. So that may be part of what's confusing me. The second thing is I see a lot of places in the document where it says things like, a TCP/CL implementation should do something, but you don't necessarily give a good indication of when it shouldn't. And so it may be useful to say, if you really think it's a should, then give an example of either where that would be true or a case where it would not be true. And with my background, I can tell you that if you don't do that, you're going to get a lot of comments during IESG review going, okay, so when do I make a decision as to do this or not do this?
Okay.
And that kind of led to a kind of generic statement that I made to Rick earlier is that it may be useful to have something like a state diagram that describes when you move from these different points to other points and what the decision would have to be in order to make those moves.
Brian, can you make some of those comments on the list so we've
Yes,
got a record? I know Ed's taking notes, but it's useful to have
Right.
these comments on the list.
Yep.
So I recommend we move straight on to Vicky, and then we hopefully can have a discussion about what the working group thinks reactive fragmentation is, how much lives in which layer, and how we can really make some progress by simplifying it down to a basic set of rules. But thanks, Brian.
Sure.
Stay in the big box.
Can everyone hear me? I do have a tendency to mumble, so give me a shout if you can't hear me properly. First of all, I just want to say thanks to Brian for all the time that he's putting into this. I know I've given him a lot of grief recently, but he's taken the time to go and reply to every single comment, so thank you for basically all the work that you're doing. The comments that I've got today are on the most recent changes, so bringing back in the contact header extension to sort out the reactive fragmentation and some of those signals that go between the convergence layer and the bundle protocol agent. So next slide, please. I found this quote, which I thought might be quite useful to set the scene a little bit. So reactive fragmentation, if the bundle is only partially transferred, the receiving bundle layer would modify the bundle to create a fragment from it and forward that on however it would normally. But also it's looking for feedback from the convergence layer to see how much actually did get sent and acknowledged, so that it can create the second fragment.
Next slide.
Yep.
Sorry.
So the contents of the draft at the moment that talk about the reactive fragmentation, we negotiate that in the contact header using the extension item, like Brian mentioned. So that it consists of flags, which there's a critical flag, which in the draft it says, if the critical flag is set, it means the peer node has to interpret and negotiate the reactive fragmentation capability. To me, that wasn't really clear what that meant, but I'll get onto that in a minute. So it's got the type, which is reactive fragment, and the actual value of it then is a 1-octet flags field. 2 flags in that can generate, which says that the sending node can generate reactively fragmented bundles, so it wants that feedback on how much did actually get acknowledged. And can receive is then for the other side to say that I'm quite happy to pass up a partially transferred bundle, and then the bundle layer is capable of forwarding that on as its own fragment. So the idea is then that if the sender can generate reactive fragments and the receiver can receive them, the convergence layer then will pass it, well, it'll get acknowledgements for all the received data, so all the segments that get sent through. And if the transfer then fails, it can tell the bundle protocol agent so that it can form a smaller bundle with the unacknowledged section of that bundle. On the receiving side, the convergence layer would hand the bundle data upwards to the agent, even if the transfer failed, so that it can then create a fragment from that, and it would then trust that the sender is also creating the second fragment from the stuff that didn't get transferred. Next slide, please. So what I wasn't sure about was if there are other combinations rather than just the happy I can generate and I can receive. So if one side sends that extension header and the other doesn't, it says in the draft that no reactive fragmentation would occur. But what confused me was if there was different combinations of having the critical flag and then different combinations of can generate on one side and can receive on the other. But I think in most cases, you probably want to establish the session, but disable acknowledgements. One other point that I wanted to make on this was that since in that TCP/CL session, both peers can then initiate transfers, so a bundle can go in either direction. If there's a strange combination of the can generate and the can receive, does it kind of limit that session to one-way transfer? And would you check that contact header information basically for the start of a transfer in each direction to see if that transfer would then use reactive fragmentation? The other thing, as I was reading through the draft, it wasn't really clear to me when the data that gets received gets actually transferred up to the bundle protocol agent. It does say in the draft, it hints at it in a few places, that the bundle data can be inspected by a bundle protocol agent, so that then the bundle could just be refused. So I guess that's happening as the segments come in, but it wasn't really clear to me. And then part of another discussion we mentioned, would there be a threshold on the amount of data that you should receive before you should consider doing a reactive fragmentation? Next slide, please. The other new part of the draft is to do with the signals that come between the convergence layer and the bundle protocol agent, so I thought I'd do a bit of a summary of those.
Can I hold you there a second? Does anyone have any immediate questions on the reactive fragmentation behavior and so on, or do you want to hold those questions till after the end of the thing? We'll hold. Okay. Carry on.
Cool. So this slide shows a bunch of the session-related ones. So the bundle protocol agent can tell the convergence layer, try to set up a session for me. I can also say shut down. And then the signals that go the other way are the session has started, which is that the TCP connection's open. So I wondered if that was actually a useful signal or not, because we've also got this session established one, which is basically the TCP/CL session is up and running. Exchange the contact headers, it's ready to use. And then the bundle protocol agent would also get feedback if the session got shut down or if it failed. Next slide, please. The ones that are related to sending a bundle. So the bundle protocol agent would tell the convergence layer, begin a transmission, it would give it a bundle. There's one in there at the moment that says the convergence layer would indicate transmission availability, so the fact that the session is open but idle. I was wondering if we really get the same information from the fact that we get the session established signal, and also we know if we've begun a transmission, then we know if it's succeeded or failed, because there's another signal for that. The other ones there are transmission success, so the bundle's fully transferred, and intermediate progress. So I wasn't sure, the quote in the draft is that this is at the granularity of each transferred segment. So I was wondering if that's the number of bytes that's been acknowledged so far, if that gets passed up for every segment that gets acknowledged, and also transmission failure. So I was wondering, instead of the intermediate progress, is it worth just saying transmission failed, but we sent this many bytes through? In that section of the draft as well, it also says that TCP/CL supports indication of reasons for the transmission failure. So I was wondering then if that meant that those reason codes should go up to the bundle protocol agent or not. Wasn't really clear on that. Go to the next slide, please. On the receiving side, again, we've got that intermediate progress. So I was wondering if that probably meant that data as it comes in, every segment gets transferred up to the bundle protocol agent. And there are various areas in the draft which kind of hint at that, and the fact that the bundle protocol agent can inspect that bundle and is able to then refuse it. Which is the second signal is from the bundle protocol agent downwards saying interrupt that reception. And then the other two are the convergence layer saying that bundle was fully received or it failed. Cool. So that's kind of the stuff that covers the reactive fragmentation. I don't know if there's any comments on any of that.
From my perspective, some of these questions hint at a layering model in there. So, and I know Brian's spoken about this before, which is the convergence there really should be just shoveling the bytes of a bundle and notifying up to the bundle processing agent that I have a bundle, I only got the first half of a bundle per se, or it's failed, don't expect any more bundles from me. I think some of the complication comes where you get that intermediate, beg your pardon, you get that progress feedback is starting to blur the lines, and it's a question to the working group: is do we care about this layering enough, or is it just seen as a sort of computer science seem nice to have, or does it have value to stick slightly more formally to this separation? Which, so that's an open question.
Scott Bailey, JPL. I think the layering is important. I think sticking to clean layering is important, and I think in particular it's important because TCP/CL is not the only convergence layer, right? There are going to be others. There are others. There could be others that are similarly capable of doing reactive fragmentation. I think we want to have a common framework for all those things. We don't want to like reinvent it for every single one. So I think the key to doing that is maintaining a clean layering between bundle protocol and the convergence layer. As Vicky was speaking, I was thinking, what is there a simpler way to do all this? And my first thought was, why don't we just set a flag in the bundle and not have the convergence layer do it? The problem with that is that then the convergence layer has to parse the bundle and pick it out of the flag, out of the bundle. So what I think is possible is to simplify the negotiation. And the thing that came to my mind as I was doing this was this. I would propose that we have a flag in the segments of the convergence layer protocol, essentially.
Do you mean the transfer in it? There's a start of an individual transfer header, which you could
I think it might be like a bit to set in every segment, because if you miss the first one, you don't know what to do. And I think it only costs a bit, and I'm inclined to think that it just needs to be there in each one, just so that you always have it. And that the intent of that flag would be, it would be set by the sender, and it would be different hop by hop because it's convergence layer. And what the flag would signify is that I require that you fragment this bundle, reactively fragment the bundle if it's incomplete. Now the sender requiring it doesn't mean that the receiver has to comply. It's that this is what the sender is intending, because the sender is committing to being able to do the sending end of the reactive fragmentation by setting this flag. When the receiver receives the data, if it determines that there's an incomplete reception, then if the sender essentially authorized reactive fragmentation, and if it is able to do it, it does the reactive fragmentation. It signals to the sender whether or not it is doing this by the presence or absence of the interim acknowledgements. So if the receiver is, if the sender signals that reactive fragmentation is required on this bundle, and the receiver is able to do it, then interim progress acknowledgements come back so that the sender knows and has the information to do the fragmentation. If either the flag is not set or the receiver is unable to do the reactive fragmentation, then there should be no interim, no progress acknowledgements coming back, only an acknowledgement at the end, whether it's all received or none received. So the negotiation is actually pretty simple, and the processing is pretty straightforward. The absence or presence of the interim progress acknowledgements indicates whether or not the reactive fragmentation can happen and will happen.
Okay, Rick speaking personally, chair hat off. I take your point. What happens if somebody, am I allowed to change that flag during the transmission? Or once I commit to it, do I commit to it? Or do we use this as, I'll flip it when I've got to it, as if I'm the sender, I'll suddenly start setting this bit when I believe I've sent you enough data that now reactive starts to make sense.
Exactly. Because it's a convergence layer, by definition, it's hop by hop. So it's different on every hop of the end-to-end path, because it's really a function of what the sending node can do and what the receiving node can do. And it would be an implementation detail how the sending node bundle protocol agent would convey this information to the convergence layer adapter. The convergence layer adapter then would be responsible for setting the flag in the segments that pass to its peer.
Just as a clarification point, because Scott and I are sort of continuing a conversation, or Vicky, Scott and I are sort of continuing a conversation we had earlier. We're trying to, when we say reactive fragmentation, we are focusing on a single use case, which is, I am the sender is sending a very big bundle to Scott, and halfway through the transmission, the line goes down, the transmission breaks. What I don't want to do is throw away all information that I've just, the 1 gig of the 2 gig I've sent to him. I don't want to resend next time round. And that's all we're trying to scope reactive fragmentation to, is the recovery on line failure. And I expect Ronald's going to say, but there are some really cool, exciting things you can do with reactive fragmentation, but that is out of scope at this point.
On the contrary.
Go on then.
On Infeld, I don't quite understand why reactive fragmentation is now rearing its ugly head again, because I think at the beginning of this working group, it was established that there are all sorts of security complications associated with the use of reactive fragmentation. And I've been sort of half following the discussion on the mail list some time back. I never saw an email from Ed Burain, so maybe he was not aware or was busy or he thought everything was okay, but I would like to invite him to comment on this.
Scott Burley, JPL. I'm not a big fan of reactive fragmentation, and I would just assume it went away completely. But if we're going to be doing it, I think the security concern went away when we agreed that the payload block would always be the last block in the bundle, so that you could fragment and you could break partway through the payload. The security concern had been that for bundle authentication blocks, half of the bundle authentication would be a block that follows the payload, and in the event of an incomplete transfer, you couldn't validate that the bundle was okay. And I think we're past that now.
Following on from that, on a more general point, following on from Ronald, DTN is delay and disruption tolerant networking. Now, I know a lot of the delay focused members of this group don't really care about reactive because it's all about delay management. For those of us on the disruption side of it, then reactive fragmentation does make sense, because if I've got a big file and it breaks halfway through, I'd kind of like to not have to send it hard again.
There are different ways to do that.
Yeah.
Ed Burain, APL. So we've talked about a couple of things, but I have a sort of orthogonal question for the group, which is, this is starting to sound to me like the discussions we had in BP BIS regarding custody transfer, which was a feature that some people needed and some people did not, that at the high level seemed simple, but could get bogged down into details and use cases. And there was a thought of, if it is not the common case, then the standard could go forward with the common case with extensibility mechanisms for understanding how new things come to be. So my question to the work group, which is either brilliant or terrible, is there value in saying that the TCP/CL is vitally important as a draft because it shows how these three things, security and protocol and convergence layer, could work together, and that we should be focusing on a section in there that deals with how to extend it, or to accept the fact that there may be multiple other CLs in the future in some way. But is this kind of discussion necessary to hold up the TCPL right now? Is my question to the work.
In response, with my chair hat on, that is a very valid question and half the reason I wanted to have this discussion today. My response would be, if the working group says, fine, push it out, we'll do a TCP extension that, you know, as long as we've got the header, contact header, we can negotiate extensions or something, then as it currently stands, in my opinion, the TCP/CL draft alludes to, hey, you can do reactive fragmentation with this chunking and this signaling of only bit arrived and a bit didn't arrive. So I think as it currently stands, people will start to do reactive fragmentation because they think they can see the bits are there. If we don't want to do reactive fragmentation, I suggest we take it out of TCP/CL and keep it really simple, or we do reactive fragmentation and we do it properly, but that's going to delay your Ed and Scott's drafts. And that's the real question for the working group. So thank you for that.
And then just the follow-up comment to that is, in general, having some language in TCP/CL that talks about future extensibility and reserve bits is necessary for other things as well. And this may be sort of the first identified example of that.
I'm seeing everyone in the queue behind you nodding, so.
Scott Worley, GPL again. Just a comment on delay versus disruption. I think it's a very good point. I have felt for a long time that proactive fragmentation based on the data rates going over the links was at least as good a way to deal with that sort of problem as reactive fragmentation. Somewhat simpler and less of a burden on the convergence layer development. But I think the sort of thing that I was proposing a little bit earlier actually is simple enough to be workable. So in that context, it seems to me it's okay to proceed with including it in this draft if we can make something as simple as that.
Brian Haberman, and I think I'm going to make Scott's skin crawl in a second. So, two comments. The first one is you always have to be careful when you're running applications trying to play fun games with fragment sizes when you're running over top of a protocol that's already designed to do that for you. And in this case, we have it twice, right? Because TCP is going to try and figure out its maximum segment size, and an IP is going to be doing fragmentation underneath you. So you always get all sorts of interesting, potential out of order handling of packets that drive application developers crazy. The second thing to consider is reading through the reactive fragmentation description in the spec right now. I'm not sure it's going to cover all the cases correctly because I don't think there's enough information in each of the segments in order to make reassembly efficient. And just to kind of reiterate something I had said to Rick as we were running past each other in the hallway, you may want to take this completely out and actually make something that looks more like rsync running on top of TCP/CL so that you can actually do things correctly and recover very quickly because they have all sorts of hashes that allow you to identify segments and bundles and blah, 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 so that you're only transmitting the things that you really need to transmit once you reconnect with the node.
And following on from that comment, an rsync CL would be a new convergence layer. We wouldn't try and cram it into TCP, would be the...
Right, so you could actually make the decision of whether or not it sits on top of TCP/CL or if it's just its own convergence layer, period. Because it's going to run on top of TCP anyways.
Do you want to do it to see whether people want to strip out the active from TCP/CL? No. Okay, so suggestion. Oh, go on, Ed. One more. one more point. No, keep going.
No, just to speak to Ron's point about security and to Scott's point. Whenever you do reactive fragmentation, you are opening yourself up to the security concern of, to handle the case where I'm 100 bytes away from, I've received 200 gigabytes minus 100 bytes of my large bundle, and I would prefer not to go through that. Again, is handling that case, it's hard to distinguish that from the case of, yes, that's 2 gigabytes of payload, and since I don't have the last 100 bytes of it, even though the payload is the last thing in the bundle, I can generate garbage and send it to you and make that denial of service attack, particularly in DTN's denial of service attack becomes exhaustion of queuing and persistent storage as well. So there is a front-end aspect of the security that reactive fragmentation needs to address, and that needs to be addressed either by saying, I have only so much of my dedicated storage that I'm willing to use to support reactive fragmentation, or I will only do reactive fragmentation when I have something that's strongly authenticated on the front end. But there needs to be additional security mechanisms there to make sure that someone is not attacking your persistent storage, which they will do.
Or a reflection attack, or
so on and so forth.
Okay, so I have a proposal to the room, and it's always very difficult to do this over Jabber and Meet Echo, but I would like to hear a hum. So the binary proposal is, one option is we understand that reactive fragmentation is a complex issue and will need more thought, more work to either get into TCP, to get it right in TCP/CL. And the other side of that is we strip back TCP/CL to some very basic functionality to make progress so the document is clear, doesn't allude to reactive at all, so no one can try and slip it in by mistake, and we keep it clear and we get it done. So if, did any of that make any sense? So if you are in favor of continuing to work to get reactive fragmentation right in TCP/CL, please hum. That's fairly clear. And I'll ask for those who want to see it stripped out so we can see who's abstaining. If you want it stripped out and put TCP/CL back to something clean, simple, and pure, please hum. I think that's a fairly clear indication.
Can I make a comment on that?
Of course you
can. The part of it that goes into TCP/CL is not really how you do the reactive fragmentation. It's just to enable some support for it so that that can be defined in the future. So do we still need to be careful about how much is actually mentioned in TCP/CL, how we are going to support some future definition of reactive fragmentation? Or do we just want to strip that out? I don't know how careful we need to be just to enable the support for it.
Good question.
I would propose that we strip it out altogether. It's an important capability. It shows up in RFC 4358, the original architecture, and people will remember it and it will come back. But I think omitting it from this specification does no harm and possibly some good by simplifying and encouraging simple implementations.
Okay, so the comments that I made, which is why we're discussing this again now, I made comments about what do we do with the acts. So should we leave those in TCP/CL, ready for some future definition, or?
Yeah, or strip it out.
Yeah, how much are we simplifying?
So I don't have a comment to that. What I would say is this also is reminiscent of when we discussed BPSec, and there was a question as to whether we included CMS and cryptographic message syntax and blocks and so on. And the way we resolved that again was by putting in, giving some thought to extensibility. So while I am in favor of taking the reactive fragmentation bits out of this version of TCP/CL, what I would be in favor of is greatly strengthening the language of extensibility and how we create reservations, bit reservations in the headers, and also to have a discussion associated with it. If there's an example that goes with it, and that example happens to be the case of reactive fragmentation purely in an informative way for how extensibility could work, that might be a way of sort of capturing thoughts. But I think the TCP/CL needs additional language in terms of how it would be extended if this is the direction we're going to go.
Mark, as co-chair, at one point in time, I would like to hear Brian Sipos' comments on this discussion.
Here he is.
So from the purely getting the thing finished standpoint, the simplest thing would be to remove the language about fragmentation, maybe remove the notion of segmentation. So right now there is only a single extension area, which is in the contact header. But it sounds like there may be some kind of a idea of, I guess, adding also an extension area to each of the transfer init messages, so that some kind of extension policy could be applied at the individual transfer level. But I'm not sure. It really depends on how the CL is being used, in the sense that there is language in there right now describing that it's possible for a network to use the CL in a one session, one transfer mechanism. Now, there's a lot of overhead to using it this way, but it also gives you a lot of control versus keeping a session up, negotiating parameters for that session, and then those parameters are just a blanket policy for every transfer that happens between these two nodes. For me, it feels like it would be a relatively simple copy and paste sort of action to have extension items defined, extension area defined both for the session itself and for the individual transfer. And then if somebody wants to come along and say, I have a fragmentation extension for this individual transfer, and for this individual transfer, the fragmentation policy is don't bother if it's less than X number of bytes received, and do something else if it's more than Y number of bytes received, something like that. But it would be an extension item applied to the individual transfer. And going back to, this is some of Victoria's early questions, there's a little bit of description in the draft, but I mentioned this also on the mailing list, is that there's a lot of interplay between the segment sizing, which is part of the negotiated session, and what you would do with those segments, in the sense that if you really didn't care about fragmentation at all and you really wanted to take the minimum amount of overhead and simplify the actual runtime behavior of the CL as much as possible, then a blanket policy would be, I have my maximum segment size identical to my maximum bundle size, which is could be some very large value. And what that would mean is that if the sender is obeying this policy to its
It's frozen.
Okay. Well, let's move.
Okay, Pim and Brian being able to get back on again. I had 2 points. One point that I remember was I think the the idea of adding an extension area in the individual transfer header, I think actually has merit, because I think we're not the only ones who are going to think of things like this. I think that future enhancements to the protocol would come along in the future, and it's with and without that sort of a mechanism, I think they'd be more awkward. So I think it costs very little. And if it's not used, great, make it vanishingly small. But I think adding extension to the transfer initiation header, I would be in favor of that. The other thing that I think we can do that I think would again simplify the specification and would cost nothing. The interim progress acknowledgements, really the only point of those has been to support reactive fragmentation, I think. I don't think there's any other value. So I would propose that we remove those. I think what we can do and still preserve the ability to do reactive fragmentation in the future is say that there is a mechanism for sending back an acknowledgement, and in the basic specification, the received length field in the acknowledgement is always the entire length of the transfer. And without saying so, acknowledge to ourselves that in the future there might be an extension that would state conditions under which the received length value in an acknowledgement might be something other than the total length of the transfer.
Scott, before you go, Mark, as co-chair, I think I know the answer, but I want to make sure. Does this discussion has any impact on BPBS document?
No, I believe there's no impact on the BPBIS document from any of this discussion. There's a point that Brian brought up a little while ago about reassembly that I thought I would mention in passing, which is that the reassembly, to the extent that reassembly is difficult and needs more support, reassembly happens in BPBIS. The specification for reassembling fragmented bundles happens there. So if we need to do something about that, then we have to revisit reassembly in BPBIS. I think that's okay. I think we're okay currently. But if there is an issue there, then that's where that conversation needs to happen.
Could I make one reply to your comment about the intermediate progress? The other thing that enables is the inspection of the bundle by the higher layer, by the bundle protocol agent, to say, actually, I'm not interested, just reject the rest of this transfer.
I think what I'm suggesting we can remove is the acknowledgements going back to the sender. So signaling to the receiving bundle protocol agent could still happen. Okay. I think that's purely an implementation matter.
Just saying we don't need that on the sending side.
On the sending side, the sender has already decided, I want to send this.
Yeah.
Rick Taylor speaking with chair hat off. I would propose that if we're simplifying this down, I don't see the point of the segments anymore. And I think the segments is the flag that kicks off reactive fragmentation again and again. I totally agree with the point about an extension point in the transfer header as well as the contact header. So you can negotiate extensions for the entire session, or you can add an extension per transfer, whatever that might be. But I don't think in the bare, simplest form, we should bother with segments. TCP is already doing, receiver acknowledged windows and all that kind of stuff. We don't need the extra overhead of segments. So effectively, your transmission is a single segment.
Brian Haberman, I'm going to echo what Rick is saying in just slightly different way. If you have segmentation in the TCP/CL, and TCP is already doing that for you, you get these very interesting behaviors with overlapping control loops that you probably don't want when you're talking about latencies as long as what we have possibly going on here. So I think it does make sense to strip the segmentation stuff out and move that into some type of extension if people want to try and do it separately from the base spec.
Scott Burley, and I'm also endorsing this idea. I think even in the event that we come up with an extension for reactive fragmentation, I suspect that the transfer header and the interim progress report acknowledgements are sufficient, and the segmentation, the segment headers are not necessary in that event. And certainly, if we're simplifying the base specification, I don't see any need to retain the segmentation headers.
Right, Vicky, you've got 2 more slides about shutdown. Do you want to try and blast through those fairly quickly, editing on the fly in light of the previous conversation?
Is there any word from Brian again?
Sorry?
Is Brian turned back up? Or?
Oh, Brian, can you connect again? Have you got any responses? We lost you completely. As if by magic.
Yeah, I had to completely do over on my side. But yeah, it seems to be back. I missed the last thing I was talking about was the extension items and the contact header versus the individual transfers, and I caught the last half minute discussion.
Quick summary, I think, and please correct me, anyone in the room, if I get the summary wrong, is the proposal is that the extension point that exists in the contact header, we should have a similar extension point in the transfer header.
Okay.
So individual transfers could be extended in some unspecified way.
Okay.
That segmentation doesn't need to exist because it opens a can of worms where people are tempted to do the wrong thing, myself included. So a transfer effectively becomes a single segment, and TCP handles all the buffering and the windowing stuff already, and that's where we are. As good summary. I'm seeing nods. So, do you have any feedback on that?
Would the current messaging, I'm talking about the protocol messaging, would the current messaging structure then be the same, just removing any of the logic about multiple segments for a transfer? So a single transfer would amount to one transfer init and one transfer segment, although it doesn't necessarily need to be called segment anymore. Transfer data, maybe.
Scott Burley, yeah, I think that's it, is that the stream of transmission from the sender sending TCPCL to the receiving TCPCL would be essentially a stream of transmissions punctuated by transmission headers. So there'd be a transmission header, and at the end of the transmission header, then you'd commence sending data, and then there'd be the end of the data, and there'd be another transmission header.
Okay.
And then the reverse traffic would be the same acknowledgement messages that are already in the specification.
Okay, but a single one per transfer, only a single one.
Yeah, I believe so.
Okay.
Well, a single one in the sense that there would be no other punctuation in the transmission of the transfer. If it's 2 gigabytes, then you have a buffer, and you're going to do TCP sends for whatever the size of that buffer is. But that's not identifiable in the stream of data.
Yeah, over the wire. Yep.
I think, sorry, Rick, I think the proposal is that a transfer becomes an atomic thing. You either transfer a bundle or it doesn't get transferred. It does raise a question about if we put an extension point in the transfer header, then at what point does the other end get to say, I don't like that, don't send me this? So can you remind me again, do you get a transfer ACK after sending the init before you start sending data? Or do we have to now wait for the end of the entire transmission for the other end to say, I have no idea what you're talking about with that extension header?
right now, there's no opportunity to acknowledge after the init message, but there is the opportunity to reject.
So there is an opportunity there to say, shut up.
Yes, yes. Or refuse, I think is the name, refuse.
Yeah.
But would you wait for that message before you then start sending what would have been the segments, the one segment? Would you wait for that reply to?
Yeah, how long do you wait until you,
What happens if that comes in, like when you've already started sending that huge chunk of data?
Scott Burley, I would suggest, I guess, that when you get one of these refusals, the refusal will identify the transfers or something in the refusal that identifies the transfer. And, right, and what the sending TCP/CL should do is, when it's informed somehow that it has received one of these refusal messages, it should say, oh, am I still sending that? If I am, I'll stop. And if I've already finished, too bad.
but that needs to be clarified in the document. That's one of those things that does need to be clarified.
Yeah.
Okay.
Yes, that's right. Yeah, that behavior needs to be clear.
Those mechanics definitely already exist, so I'm going to take a note to add explanations.
Okay, so Brian, I'm going to put you on hold for a second because Vicky's got a couple of points about shutdown, and then hopefully we can close this whole thing with some progress. Go ahead, Vic.
Cool, so next slide, please.
You got the next to her slide. She's got two more on shutdown.
Got a couple more.
One more.
I'll try and, it's a few.
Yeah, just edit on the fly. Is it there?
It's a bit of a delay. Okay. Ooh.
There we go.
So shutdown messages, there's quite a bit scattered through the draft about when you can actually use them. So there's a list, I'll let people catch up on that, I think. One thing that the draft does say is that if you receive a shutdown, you should send the shutdown in reply, but you don't have to. So I'm not sure if that's something that we need to look at. Can we go to the next slide? So the rules that are in the draft at the moment, after sending a shutdown, you're not allowed to initiate any new transfers, but it doesn't actually say you can't accept any. And on the receiving side, it says you can't accept any, but it doesn't forbid you from initiating any. You're allowed to carry on any transfer that's in progress at the moment. So that's if there's still more segments to send. So maybe we're changing all that. That doesn't really need to be considered. But it also says that you can immediately shut down TCP connections. So you're not then able to send any ACKs if there's a transfer coming towards you. But if the session's idle, then obviously that's not an issue. Next slide, please. It doesn't mention, I don't know if it needs to or not, but it doesn't mention behavior. If you were sent another init after you'd received a shutdown, what you would actually do about it, if you'd silently ignore that, or if you'd refuse it or reject it or send a shutdown back, or
Quick question, Vic. Brian's suggestion of a state transition, a state transition diagram. Do you think that would go a long way to answering some of these questions and perhaps ironing out these else cases?
Yeah, it could be quite useful actually.
Go ahead. I'll wait.
Okay. Next slide. I'm trying to skip through some of these a bit.
Oh, I'm sorry. Go ahead, Brian.
Brian Hipperman. So what relationship do you expect to exist between the TCP/L shutdown and the TCP close that's going on underneath with the TCP connection itself?
Yeah, it's what I'm slightly confused about, and I'm trying to pick out from the description in the draft what it actually means. The thing I kind of interpreted was that when you send a shutdown message, you're basically saying, I'm not going to send you any more after this transfer finishes. But I wonder if that should be kind of, I don't want to receive any more as well. I'm not really sure.
We got Brian, so I think maybe Brian's got some answers.
Yep.
Yes, so about the shutdown, the language right now might not be exactly clear, but the intent of what's written, so because the CL itself is bidirectional, once the session is established, there's no real orientation to either of the two peers. The language right now should be that when you send a shutdown or when you receive a shutdown, at that point, neither peer is allowed to initiate a new transfer, and either peer, if they see the initiation of a new transfer, would refuse, not reject. I'm getting my language a bit messed up, but it's basically, it's an invalid message. At that point, a transfer init is not accepted. There is a signal, there is an on-the-wire message of, I got a message that I didn't expect to see at this point in the protocol, and that's what would be, I think, the response. But the shutdown is intended to be, and it should be written that way, but I can go back and look. It is intended to be symmetric in that sense, that there's no distinction between shutdown and transfer, shutdown as a sender or shutdown as a receiver. There is no mode to the peer of a session, and there is no mode to a shutdown in that sense. There's no directionality to it.
Okay, so,
But the end intent is to allow transfers to complete that are in progress versus shutting down the TCP connection means if there happened to be a transfer in progress, it's failed.
okay, so you're separating the shutdown of a transfer as opposed to also shutting down the TCP connection. Because because one way that some applications handle this is they'll do a TCP close, and that's a half close, which means they can't send any more data, but they can receive any data that's in transit.
Okay, so because the CL does acknowledgements,
Okay.
I don't believe that would be something that would work. Talking about the current 07 version of the draft and not what we were just talking about single segment behavior, until the CL transfer acknowledgement is received, the transfer itself hasn't finished, hasn't succeeded.
Okay.
So the receiver of a bundle, the receiver of a transfer, still has to send out TCP connection, TCP socket data to acknowledge the transfer.
Okay, yeah, that should be clarified, because when I read some of the description of shutdown, I see the TCP close happening when someone says a shutdown, but I think you need to clarify what you're waiting for and why the TCP connection needs to stay up.
Okay.
Brian, CPOS, would it help if Vicky actually suggested a block of text for this?
Absolutely, yeah.
Okay.
Okay, cool. I can do that.
Scott Burley again. I think it's not already clear in the spec. Maybe there needs to be some additional language to clarify it. In my mind, I would like to remove the distinction between clean and unclean shutdown and just say that shutdown always means an orderly shutdown, and it always means that upon receiving a shutdown and upon sending a shutdown, you cannot initiate any more transfers, and upon sending a shutdown and receiving a shutdown, you're required to complete reception of the current transfer. And until you have until that's done, until you completed reception of the current transfers in both directions, and there's only one because they're one at a time, until you've completed those, the shutdown is not finished, and you're not authorized to close the socket, to shut down to stop the TCP connection. Stopping the TCP connection is by definition not a shutdown. It's an anomaly, and you recover from it as it's error correction.
There's also a comment in the draft at the moment that you can't send a message, so for example, you can't send a shutdown if there's already some kind of message that's being sent. So if that segment is being sent at that moment, and it's quite a big segment, you can't then send a shutdown at the same time. You'd have to wait for that anyway.
Yeah.
So with the new bit of discussion that we've just had, would you wait for that transfer to finish and then send a shutdown afterwards? Rather than send a shutdown and then wait for the transfer to finish?
I think if it's Rick Taylor, I think if it's a graceful shutdown, then you wait for your next opportunity to say, I am going to be gracefully shutting down. And if you have to wait for your current transmission to complete before you get a chance to talk on the line, then anything else is an abort. It's I'm killing the connection.
Yeah, if it's an emergency because you mustn't transmit anymore, then just close the TCP connection and recover from that.
Yeah, everything that I've heard so far, that is absolutely the intent of the behavior.
So Ed Baraney, appeal. I am a little worried about the case that Vicki just brought up, which is if we are using this for very large transfers, and very early in the large transfer, we have decided to reverse our opinion on sending the data. And I don't know if that's a credible use case, but I'll defer to others as to whether we think that's going to happen. But if I'm 100 bytes into my 2 gigabyte transfer, and I realize, oh, these are the wrong 2 gigabytes to send, the idea that I need to take time in even a delayed hop to hop, let that thing finish, seems very wasteful to me. Shutting down the TCP connection seems drastic. Altering shutdown semantics seems drastic. So I agree with everything that Scott had said before about clean shutdowns, but it is perhaps having a cancel current transfer without shutting down and without breaking down the TCP session might be a useful thing to consider.
Rick, just quickly responding to that, I think not having the functionality you want is the price you pay for having atomic transmissions. It's a compromise, and I don't think you can have that without bringing segments back in.
Scott Burley again. Yeah, I think that since use cases for needing to stop a transmission, a 2 gigabyte transmission after you send the first 100 bytes, don't leap to mind. I suspect that this is going to happen infrequently enough that the cost of simply stopping, closing the socket and reopening the TCP connection is a reasonable cost, and the simplification I think is very valuable there. If we modify the shutdown semantics to support anything else, I think it's too much work, and I don't think it's cost justified.
Mark, co-chair. Rick and I discussed, we are aware that we are spending more time than planned on this, but at the same time, we wanted to clear this out. So I'm not saying let's finish this discussion, but continue and then try to finish. But for the presenters, we may not get time for all the presentations.
Is that your final slide?
I had a couple of notes there on unclean shutdown, which is basically, I thought the definition of it was maybe a little bit off. And my suggestion was that an unclean shutdown was closing the TCP connection before the transfer had finished. So I think that kind of relates to all the discussion we just had. I think on the final slide, this is not the next one, the next one after. Oh no, those 2 comments there were just sentences I didn't quite think made sense or could be misinterpreted. We can move on. So the reason code. So if there's a transfer in progress and you send a shutdown with a reason code, the only one that's relevant is resource exhaustion. But then the draft says that you should try and finish your transfers. So it didn't quite make sense to me. And the other thing was that you can put in a reconnection delay in your shutdown message, and you could send a 0, which means never reconnect. So I wondered if that was a sensible thing to do or not. And that kind of covers my points, really.
Scott Burley on these 2 points. I think a good point about transfers in progress and relevant code being resource exhaustion. Does it make sense that you're allowing transfer to finish? I think I'm I think maybe we can recast that as anticipated resource exhaustion, meaning we have to allow this transfer to finish, but I don't have room for anything more than this. And it's possible, but I'm actually out of resources altogether, and I'm going to throw the whole thing away. But that's my business and not yours. So I think it's okay. And on the last point, I think the never reconnect. I think you can always undo things by management. So I think it's maybe maybe sending a zero reconnection delay is unwise, and it may be that implementations should avoid doing that, but maybe having the capability there is not unreasonable.
Rick Taylor, responding to Scott's comment, I think sending zero never reconnect is dangerous for two reasons. One, I think it might be abusable. And two, I think somebody might look at that and go, hey, I can do routing with this. I can say, I don't want you to send me that kind of data anymore, and sneak it in through the back door, and we're trying to trim stuff out of TCP/CL that can be abused for other reasons.
Scott Borelli again, sure, I'm fine with that.
Any more comments?
Brian,
Okay.
any further comments? Yep.
I'm taking a note to remove the zero as a valid value in the reconnection delay and anything that's related to that zero value. I don't have any problem with that. And then on the resource exhaustion reason code, I believe that was really just intended to be to catch a whole. I don't believe that code was in V3 of the CL spec, and I think it was added just to cover the whole of. I don't want to accept a connection, or I want to shut down the connection. It doesn't really say what resources are being exhausted. It could be that the total number of TCP/CL sessions that a node has established hit some limit or hit some above some soft threshold, and I'm closing this session because I've run up against my limit of how many sessions I should be allowed to have, that kind of thing. It doesn't necessarily mean my disk is full or my RAM is full.
That's fair enough. That's my lack of experience then that made me make that comment.
It really is just supposed to be a catch-all of I've run up against some limit and I don't want this session any longer.
Rick Taylor here. I think with the removal of the segmentation, the fact that you can no longer shut down within a transfer, I think a lot of these boil off. I actually think some of the shutdown codes are really aborts anyway, and the ability to say something complex has happened that means I can't recover, you've probably aborted before then. So in my personal opinion, some of these can be trimmed down to stuff the other end can do something with that information. I mean, if it's like, I've crashed with this pointer exception, the other end doesn't care. You've died.
Yeah.
So, co-chair hat on, does anyone else want to pick apart at TCP/CL, reactive fragmentation, transfers, this whole topic? Does anyone else have any comment before we move on to the next subject? Thanks, Vic.
Okay, so I think we have a path forward. Brian, we're expecting a new version of the draft as soon as you could, with the reactive fragmentation and segmentation essentially out, and a few other fixes that we discussed.
Would people be interested in the virtual? Do you think it's worth it?
That's a good question.
Would people be interested in a virtual interim meeting to just try and stay on top of this and make sure that we're making progress? Brian, I'm hoping you're not going on vacation for the next month. And I know we've got public holidays coming up. We do in the UK. So we can look at maybe 4 to 6 weeks or something like that if we can get a draft out. But, let's not commit to anything now, but we can. Okay.
So, Ed Brain, APL, yes, I think that's a great idea, and I would second it. I would suggest that if we do that, there may be an opportunity because there's an upcoming CCSDS meeting that is close to where several people are who are working on this. If that happens in the April timeframe, we could get a group of people together in April to sort of work through text for that. So if we were to have an interim meeting in the May timeframe, maybe there is a chance that we could produce something for review at that time.
Obviously, the mailing list would be included on that sort of stuff, so any kind of private meetings wouldn't actually be private, they'd be minuted and so on and so forth. But yeah, no, I think it seems reasonable. Okay, so thank you, Vicky and Brian. Ed, do you want to say a few words on your BPSec interoperability suites? I know we're going to try and cram down to highlights if people can try and be reasonably quick.
But I only have highlights.
Can you do highlights?
Very, very highlights. Give me a sec.
Too many monitors.
And not the right thing. I misused to. Yeah, this one.
That one. That one. Yeah.
Oh, excellent. So, my name is Ed Brain. I wanted to talk briefly about BPSec and the interoperability suites. If we go to the next slide. So, my understanding is that BPSec at this point has gone into working group last call. I believe that at this point, BPSec as a document has also been requested for security AD review, and I'm not aware of any open comments on the BPSec spec, although I certainly encourage anyone here to read through it in the context of last call and get back to us into the list with any changes. So given that, something that came up at a prior meeting 2 or 3 meetings ago was the idea that we really need an interoperability spec, not necessarily an operational interoperability spec, but at least a testing interoperability spec to make sure that people understand how this can be used. And we said that we would write a very short document, and it is a very short document, maybe 8 pages total, which is a draft that says, here's an example of an integrity cipher suite and an example of a confidentiality cipher suite and how you would use them in the context of BPSec. We have picked for integrity, HMAC 256, SHA 256, and we had picked for confidentiality, AS/GCM 128. Selecting GCM does make things a little bit easier in the sense that your payload and your ciphertext are the same size, and that spec is out there for review. At the last working group meeting, we had also requested or asked the question whether this internet draft should also be adopted by the working group, because it would need to be adopted by the working group in order for it to also go in as a necessary condition for getting BPSec through ISG review. Next slide. In terms of updates, the kinds of things that this specification does is it lays out how we refer to these particular cipher suites in the context of BPSec. Wherever possible, we have pointed to other documents that discuss how you configure the specification. We're trying not to invent sort of whole new enumerations, but we do need something that says this is how the parameters identified, and these are how the cipher suite results are identified in BPSec. So we have some tables like this in the spec. Next slide.
Oops, sorry.
Same thing for the security results. None of this is new to the spec. Next slide. In terms of what has changed, I fixed a few typos since the last time. We clarified in the introduction that this does not necessarily imply operation. It is certainly here for interoperability testing. And we clarified a couple of items in terms of the parameter definitions and the result definitions. Specifically that for this cipher suite, you must encrypt the entire payload of the target block instead of portions. And that, just to clarify for those who aren't familiar with GCM, that in this case, the ciphertext and the plain text would be the same size. So at this point, the requests are whether we would adopt this as a working group document and whether we can get additional reviews if anyone feels that there's more to be said about how to configure these specific cipher suites for interoperability testing for BPSec.
Thank you, Ed. Oh, so I think off the back of that, we'll ask on the mailing list for working group adoption of this, and if people are keen, we can get the ball rolling on that kind of stuff. Thanks. You what next? I've lost the agenda.
Okay, next slide. I'm still Ed Barain. I'm still from APL. So we had been talking before about network management and what network management would mean in the context of a delay-tolerant network. We had put together a internet draft called the Asynchronous Management Architecture, which was our definition particularly of what an autonomy model would look like and an automation model would look like for a DTN. That AMA document has been unchanged for the past one or two IETFs. At the last IETF, we had said that there would also be a request to look at this as a working group document. I don't know the status of that, but would request the status of that. And then sort of finally, what we have done is, given that the AMA is at least we're not currently adding to it because we don't have any additional comments from it, we think it's in good shape. We came back and said, if we were to create a data model to that AMA that captures the kind of autonomy that we would like to see, what would that look like in the context of some of our own reference implementations? Something that we've looked at as we've talked more with other working groups in the IETF is there is a renewed interest or a more converging set of interests in automated network management. We have been doing our best to keep in front of those and to understand what those sensibilities are. And we're still trying to find something that works in a very embedded space for us. In particular, we want to make sure that the existing protocols that are coming out for automated network management aren't too verbose. Layering some level of autonomy on top of a stack that we already are concerned about deploying in a delay-tolerant area isn't going to help solve our problems. If we don't have sufficient autonomy, if autonomy becomes how do we summarize existing data sets and that's it, then that also isn't helpful for this community. And in particular, a lot of the automated network management that we're seeing coming aboard is still relying on very synchronous and tight control loops for configuration. And that also doesn't help. So we believe that the data model in the AMA that we've put together is still unique and relevant in this area. The next slide. So in brief, what we have started putting together is the AMA, which is an aspirational model for how we think network management should be done. We have then taken that and put in a data model together to that aspirational model. And then we are working separately on resurrecting the AMP Internet draft, which is the CBOR encoding of that model. Next slide. So in terms of logical modeling, what does all of that mean? We do have a model. We are working right now to understand whether that model can and should be modeled in Yang, particularly if we want to do the modeling in Yang but said that on the wire we wouldn't be using netconf as a protocol. What does that mean? And that is sort of an outstanding question that we have right now. Next slide. Briefly, the autonomy model that we have put together is data and constants, the ability to define operators, command and control, and variables and macros, and time and state-based rules and automation. And essentially, the claim is that this is the set of autonomy data modeling necessary to do the kind of network management that we want in a very compact and typically binary format for our resource-constrained devices. Next slide. And then what we've done is we've taken one of the reference implementations of DTN, ION, and started putting together a series of what we call application data models, which would almost be like Yang models or going back to SNMP MIBs for these things. And we've created them so that we could manage in-band ion in those ways, just to show that the specifications and the models are expressive in the ways that we need them to be expressive. Next slide. So where we are right now is for all of those models, we have created a JSON expression of those which have the sort of syntactic and semantic sugar that we would want to see in them. We have, for example, basic types of uints. We allow parameterization of basic types so that you can say, I would like this integer, but I would like, for example, the number of transmitted blocks from a particular source as opposed to breaking out and defining multiple ones. It reduces the amount of data that has to go back and forth on the wire. Next slide. We support variables and initializations for variables so that you could sort of create those in real time in the operational context of the system. Next slide. We have tables and reports, and in particular, we have things called parameterized reports. All of these sort of associative lookups and parameterized reports are ways of trying to reduce the multiple handshakes that we see in other network management systems, where you have to dump an entire array back to a requester so that they can understand what indices into a statically sized array is their particular associative lookup. Next slide. We have a series of controls, parameterized controls, and macros, which are fairly common at this point. Next slide. And constants and operators, with the idea that new MIBs actually, or new ADMs as we call them, can actually define their own operators as necessary. So that if you support that model, then here are the additional set of operators that are in your lexicon that can be used as you create your own time and state-based rules in your system. Next slide. In general, we've then taken all of this, and just to prove the concept and that the model does what we need it to do, we have some Python scripting up that will accept those JSON models and generate C APIs that work for ION, and it does sort of the round tripping that is necessary to then allow people to not only have ION auto-generated C files, but to be able to go in and just write the implementations that are specific to their needs. Next slide. And here would be an example of some auto-generated C code, where sort of at the top and the bottom are the things that are put together. The code that then populates tables and auto-generates the initializations and glues together the calls to this don't need user input and are put in automatically, and then someone can really just write the code that is necessary to perform that specific function. And since we've done that, we've been able to start rolling in new applications and models into the management of ION at a fairly rapid pace, in a couple of days, maybe a week, maybe 2 weeks if we add test code. Next slide. So where we are right now is we do have the AMA document. Everyone that we have sort of showed it to date sort of generally agrees that this is a good way of doing network management, a style of network management, asynchronous management. In this particular domain, we think that even though there is a large amount of automated network management that's coming in, it doesn't really fit this particular niche that we are working in, and that the AMA is still a good and relevant document. And there is a question as to whether it is useful to adopt it here. The ADM template as expressed in JSON is something that we're working with now, but there is a question out to the working group at large as to whether modeling, using Yang modeling at this on the back end from a schema perspective is a useful thing to do, or is it just confusing if netconf is not the wire protocol? And then otherwise, probably by the next IETF, there will be at least an internet draft which shows an encoding and a reference implementation of this, just as a way of validating that we believe the model is correct and expresses what we need it to express.
Okay, Rick, I have, on behalf of Ed, and I have some interest in this work going forwards, I've been going around the various Yang doctors in NetMod and NetConf group, and the latest best advice I've had on if the working group was try to take this on, we would be suggested to do the work in this group. If we found issues with Yang that wouldn't fit our modeling, we would generate a document which we would then take to NetMod to say, we like your Yang, but it doesn't work in our use case, and give them the problem to solve. Obviously, they'd ask for our help in solving that. But the feedback I'm getting is no other working group, particularly not the core NetConf NetMod guys, are going to take on this work. We should do it here and send them basically change requests.
So that's reasonable, because I would also claim that no other working group is trying to solve the problems that we are trying to solve, and that makes perfect sense. It would be nice to be able to come forward and say, here is an ecosystem that we can demonstrate does what we need it to do with the performance requirements that we have. We would like to adopt Yang with these changes, and we could give very specific recommendations.
On that, on that note, with my chair hat on, I'll need to check to see how much of this is actually chartered work. I think there's an architecture that's part of the charter, but whether actually working on this is chartered, I'm not sure. And also we have to be, Mark is saying no, we need to make sure that we get these core triumvirate documents out first, and then there might be an opportunity to have a discussion about whether the charter is still making sense. But that's, I think, is going to be post those 3 documents. So although Ed is keen to push this work forwards, adoption and so on is going to be on hold until we can get TCP, BPSec, and BPBIS done.
So also agreed. The existing charter has some language regarding network management requirements. This kind of data model is not network management requirements. There was a question as to whether the AMA was close enough to specifying what network management should be doing, that it would count as requirements. But I don't think any of this should take time away from the working group in getting the core specifications through.
Cool. Thank you. And on that bombshell, we'll move on to the next presentation so we don't take any more of the working group's time.
Oh, great. Thanks. I'm Scott Burley, I work at JPL. The slides here, I'm heavily indebted to Kapali Viswanathan for putting the slides together. We've been working very closely on this for the last, it's going on a year now. And there's been very good interchange of ideas, and I think the document is a lot stronger as a result. Next slide.
Have you touched something? Oh,
Sorry.
Unfortunately, something was touched. Okay. I will try to go through this very quickly. The deal here is that public key infrastructure is arguably an important function for delay-tolerant networking, but in DTN, we cannot rely on the ability to do on-demand or interactive communication. So the existing public key infrastructure mechanisms are not really usable, so we needed something new that was DTN friendly for distribution of public keys and key revocation. Next slide. Here again, this, and I won't go into detail, this is a general picture of the overall structure. The idea is that there is an aggregate key authority that comprises multiple key agents. The multiple key agents reach consensus among themselves about key information that, public key information, assertions and revocations that should be distributed to the network. They periodically reach that consensus and then issue bulletins. The reaching of consensus among the key agents needs to happen in a timely fashion. So typically you expect it to happen over, for example, the internet, some or at least notionally non-delay and disruption afflicted networks, so that consensus can be reached in a timely way. And then that once that consensus bulletin has been agreed upon, the bulletin is chopped up into pieces. Each of the members of the aggregate key authority is responsible for sending some subset of those pieces. The pieces that are sent out by each of the individual members of the aggregate authority are multicast to entities that need that key information, here shown as DTK key users. So the DTK key owner who generates a public-private key pair retains the private key locally and never discloses it to anybody, and then sends the public key to the members of the aggregate key authority. the key authority members collect that stuff over time, reach a agreement on what they're going to send out, and multicast it out to the key users. There is configuration involved in doing this. That is, the public keys of the key agents have to be known to all of the key entities and the DTKA key owners and users, so that the transmission of data to and from the key authority can be authenticated. And there's a new thing called trust model number configuration, which I'll come to in a minute. This is new in this version. Next slide. This is a general picture of what I was just talking about, the authentication of a bulletin, the key owner that generates the new public-private key pair transmits that its own ID and the key to the members of the key authority, and the key authority then sends the bundle off to the key users, the bulletin rather, off to the key users. Next slide. There was some feedback from the original presentation of this material at the last IETF. There are 3 items in particular. First, what happens if some bulletins are missed by key users? How would they know, and how would they recover from that failure? In theory, this shouldn't happen very often, because the pieces of the bulletin are sent. There's some redundancy in that. Multiple key agents will send some of the same pieces, and the bulletin as a whole is erasure coded, so that there are parity blocks going out as well, to minimize the chance that anybody will lose a bulletin completely. But it's still possible, and so how do you recover from that? The second item of feedback was a question about using different trust models for accepting keys and revoking keys. That is, could a different population of key agents be responsible for revoking keys, different from the population that's responsible for accepting them? And the third item of feedback was whether or not the consensus mechanism for reaching consensus among the key agents needed to be documented in the draft. Next slide. So responding to the first of those feedback items, yeah, great idea. So there's in the new bulletin structure, there is a new field, the bulletin serial number. The idea is that that the key authority in aggregate would issue bulletins serially, and there would be numbers attached to those bulletins saying which bulletin it was. Not a particularly radical idea. That's something I missed. It's not a monotonously increasing number. It's a monotonically increasing number. It may be monotonous also. The receivers would store the bundles, serial numbers of the bundles that were received, and so you could, as a receiver, you could, when you receive a bundle, when you recover a bundle from a bunch of when you recover a bulletin from a bunch of bulletin segments, you could say, oh, here's bulletin so-and-so, but what happened to bulletin so-and-so -1? I don't have it. And there's a mechanism defined in the new draft for requesting that key agents retransmit bulletins that are not received. This would be an ad hoc and we hope rarely used facility, because it is conversational. It would take conceivably some time. It could take a week for this kind of recovery to happen. And so there's always the possibility of error conditions, and we hope to minimize this with heavy encoding of and redundant transmission of the segments of bulletins. But just in case none of that works, this is how you recover. Next slide. Multiple trust models. There's a new field in the bulletin called the trust model number. And what that amounts to is a different, let's see, let me restate this. The key users and key owners know and have to know in advance the public keys of the key agents that make up the aggregate key authority. All this does is say, oh, there might be multiple sets of key agents. That is, in effect, multiple key authorities nominally under the same actual management authority that would be responsible for different operations on the network. An example of that would be you might have a different, functionally a different key authority, a different set of key agents for key revocation than the set that would be engaged in key assertion. But the mechanism is general. You might use this mechanism to have different trust models for a variety of other reasons to be determined. And there again, these definitions have to be loaded into each DTK entity during bootstrapping. It ultimately will be necessary to modify those things after operations begins.
Scott, sorry, as a warning, you're eating into your next presentation slide because we're very tight on time.
Okay,
so.
almost done, I think. And there needs to be a protocol defined for that. We haven't done that yet. And whether it needs to be part of this specification or not, we need to discuss. This is still not the final draft, I think. Next slide. We talked it over and decided that the consensus mechanism was an implementation detail that we shouldn't try to define in this specification because it doesn't really affect interoperability between the key authorities and the key users. And this would be a thing we can discuss, but I think it simplifies the specification in a useful way to leave it out of the draft. Next slide. And one more update is adding an additional message type to distinguish between assertions that are authenticated by an out-of-band mechanism, such as a direct connection or intervention of a human operator, and assertions that are authenticated by being asserted by a node that already has a known public key, which could be when you roll over your key, you do that yourself. When you're starting up, maybe the node that created you is already trusted and it asserts your initial key on your behalf. Next slide. That's it.
Quick question. Are you asking for working group adoption of this?
No, not yet. We haven't talked this over, but I think we're interested in feedback from the working group. I think there may be a couple more things as we're going through here that we still need to add. So I think it's premature, but I think with any luck, we will ask for working group adoption at the Montreal.
Naglasher, individual. Who is generating the bulletin?
I'm sorry, say again?
Who is generating the bulletin? The bulletin.
Oh, the bulletin is generated by the aggregate key authority, which is the cooperation among all of the key agents. So the key authority is multiple agents.
And your who is going to decide the new serial number then, if there are multiple agents where they could be out of sync or?
This is why the key agents themselves, the members of the aggregate key authority, need to be on a network that is essentially non-delay tolerant. That consensus mechanism needs to happen in a timely way, and part of that consensus mechanism would be coordination of the bulletin numbers.
So they would need to have kind of a mechanism where the I need another number, and the others agree, and that all kind of stuff.
So the way I imagine it works is that the key authority in aggregate generates a bulletin, say, once a day. And so once a day at a given time, they're all going to exchange messages contributing to the development of the bulletin. At the end of the day, they're going to say, well, okay, here's the one, here's bulletin number 613, because it's the 613th time we've done this. Because they've reached consensus on the content, it should be straightforward for them to reach consensus on what day it is.
Looks fragile to me, but
Sorry?
looks fragile to me.
I think it's okay. The reaching consensus on the bulletin itself and the hash on the bulletin, which actually identifies the bulletin, we already have implementation. So it's a doable thing. And I think adding the number, I mean, in the hash almost functions as the number, except that it's not sequential. And having an additional sequential number should not be challenging.
Scott, I'm looking through the agenda at the moment. I didn't have any slides for your.
No, there's no slides for what's the last item?
You said you wanted to say something about bundle and bundle encapsulation and custody transfer.
Oh, and I think the only thing to say there is to ask if there were any questions on it and if there needed to be any discussion. I don't have any new material to put.
That might be one
present
on
on.
the list then.
Yeah,
I might
yeah.
suggest.
Yeah, we can, if there were time today and if there were questions, it'd be a good opportunity to talk about it, but I don't think there is.
But one last thing I can try and squeeze in is Felix was at the hackathon who managed to get a Python-based BPBIS working. Do you want to say a couple of quick words? Just, or we can just say, well done, thank you for doing it.
Yeah, so I mean, I would have some small demos, so if one of you wants to see it at the end, I can show it to you. So, but what we actually did at the hackathon was, so I met with some guys from Xworks, which is a Slovak IT company, and we just wanted to check whether the BPBIS implementation inside MicroPCN, which I'm a developer of, meets the current draft version of BPBIS. And so we developed an alternative BPBIS implementation in Python as a proof of concept. And as a result of the hackathon, we have communicated successfully with MicroPCN. We built a small REST API to push some contact plans and bundles to MicroPCN. And we also built a test setup, which is reproducible through Docker containers. And in the course of the hackathon, also MicroPCN bundle BPBIS implementation was updated from the current draft version 06, I think, to the current version 10. And we switched the somewhat easy CL implementation, which was inside MicroPCN, the default, to the TCP CL, although still version 3 in that case. So I think it was pretty successful. It was fun to work with the guys from Xworks, and we have found no additional issues in the BPBIS draft. So I think it's ready to become standard now.
Thank you very much. That's very useful. Any other business? Does anyone else have any comments? Anything? We have 3 minutes left, so well done everyone for keeping things short and to the point. I hope you don't mind going through that TCP/CL thing. It was something I pushed for because I think we've made some progress and got some consensus there. And otherwise, thank you for coming. And speech on the list. Comments, please. Blue sheets, if people have done blue sheets. Oh, shit, I need applause. We got blue sheets, we got everything. Yeah, brilliant. Thanks, guys. Oh, so I'm going to electrocute myself.
Yes, well, maybe in Montreal, we'll remove yet another thing in the protocol suite.
Let's just go to the crypto.
Security, too complicated. Yes. Just